Alright, guys. Okay, Chapter 10, Railway Planning. Railway planning consists of determining what type of the railway system is needed. It also includes what type of the service will be used and who will use it and maintain the railway system. Railway intelligence. Railway line and equipment planners and operators, either before and after entry in the theater of the operation, should gain more information as possible on the railway system that they will be using for operation. The following sample listing information that they should maintain in the operation: type of locomotive, the manufacturer, model, horsepower number, the gauge, mechanical condition, and if they spare the parts available in the area. The type of the rolling stock number, the loading limits to the repair and condition and part availability distribution within the system, single system type of operation, if any, in the state of the repair and effectiveness. Track structure, the size, type of the rails, condition, and cross size rail ballast without the rock sliding potential number, signal, double main lines, or availability of sidings of the passing of the tracks. Laying out of the system, the branch line, grade lines, curves, bridges, tunnels, clearance limitations, both height and size, side clearance, and methods of operation, fleet blocking, automation method, any very good system, electronically communication must exist, but be put on use on the railway system. On other matters concerning the railway intelligence can be found in Chapter 3. Railway operation planning, staff and planning functions of for theater railway operation. Responsibility for the commander, first echelon of the unit in theater. The railway plan is developed and integrated over all movements of the plan in the theater. Selected personnel in the transportation railway battalion obtained by the most detailed intelligence data through the reconnaissance of the captured and liberated railway lines. Augmented personnel of the higher echelon railway units, railway battalion commanders who have assigned the division of the railway line and conducting the reconnaissance of the respective rail divisions, gathering the intelligence that make the estimates that make time required of the line operational and the capacity of the net tonnage that can be moved over the line. The intelligence information control are collected and planned and estimated, formulated as forwarded as the next command level. Here are all the information, the estimates, and the battalions are consolidated into the form of the transportation railway line. The planner, the assumption based on the information he has or on the post past railway operation experience, if required, if the information is not available or cannot be easily obtained. The following are some important items the planner shall consider. Strategic importance of any selection of the certain railway lines and plan strategic acts of the plan, objective of the operational line, advancements, enemy strengths and disposition, influences the selecting a primary alternate railway lines. Details shown on the maps of photography, such as railway routes, number, the location, railway facilities, number, and kind of structure. General description of the railway system, the facilities, and equipment. Descriptions and help the primary planner determine the potential capacity of the system, the importance of the system, the economical structure of the country which is located. Description should be given in the information ownership of the railway and general operating procedures, the organization, detail, basic characteristic route facilities, equipment, structures, and operation. The details of the planner to estimate the more accurate railway capacity and intelligence data should be detailed in such items as the right of way, the roadbed, track, and types of the amount of the equipment, supply, maintenance factors, such as the spare parts, engine house, facilities, and fuels, and water stations available at personnel. The type of the gauge of the classification railways in the area, the general gauge classification standard, broad, narrow, and meter for the defensive reason. Nearby countries, often not construction railways, having the same type of the gauge. For some precaution, ensure that one of the gauge does not operate on another. 10.3. The planner must also consider the physical features of the area when selecting the railways. Consideration of the following: adequate yards, terminals, shops, and facilities. With adequate yards and terminals and main lines being congested, the terminal yards should have the sufficient track for the receiving the trains, classifying, making up the trains, and the department of the track should be long enough to receive the longest train without dividing it into two segments. Intending to operate on a rail division, the facilities are needed on the spot. To spot them, unload them properly, return them to empty services. The terminal should include the engine house, a car repair, a fuel loop, sanding, water station, buildings, and to house the crews of the railway battalion, the heavy repair, maintenance of the railway equipment, adequate shops, and located near yard terminals. Single and double the multiple tracks. Train density, overall railway capability of greatly affected by the time of the numbers. If there is a usable double track, may use both directions without delaying the schedule. However, the unit is often takes the usable parts of the damaged double track to make one single main line good passing tracks. Seasoned roadbed and good ballast and heavy rail. The road ballast and the weight of the rails after the speed of the weight of the rails. The weight railway within the season road bed of the red ballast and the heavy rail is the selected number that interruptions of the train operation caused with the washouts buckled to the rails and generally reduced. Slightly greater the curve the trains operated in the mountains, the steep the grades required, but the motive power steep grade usually requires pusher engines at the rear of the two of the more locomotives pulling the double header in the front of the train, or in the short train operation mountainous terrain. It also reduces the train speed. Strong pulling and the sudden braking or hard on the rail cars sometimes causes derailments. This car requires more maintenance than they should use fairly level grade. Running time. The running time is greatly increased if the line of the sharp and long curves of the speed can be reached. A straight run of the track cannot be maintained on the curve of the track. The ideal way with no grades of curves, near realized. However, the rail with slightest and the fewest gentle curves shall be selected. Adequate sidings and spurs passing to the tracks can be long enough to permit the longest of the division to be able to completely clear the mainline track of the siding spurs to the desired that are not major bases in selecting the railway lines. Stone bridges and tunnels of sufficient clearance. The strength of the railway bridges effects on the kind of locomotives operated over them. The bridges must be rehabilitated and constructed that they must be strong enough to have the support of the locomotive's desired train weight, and any tunnels of the railway should have an clearance of the wide of the heavy loads and such as bulldozers and crane to pass. 10.4. 10.4. We are selecting railway lines to carry part of the taken to those selected, those at least vulnerable to track interruptions. The following are some potential bottlenecks that are vulnerable to the enemy action and natural force. Tunnels, long high bridges over the deep stream valleys, deep cuts to the high fills, limited access terminal yards, tracks located adjacent to the banks of the streams. These tracks are subject to the erosion action of the flood weathers. Restricted clearance, pointings in the track running through the cuts of where the land route slides are common. Okay, 10.5. While military supply movements are primarily forward, military line capacity estimates are used based on a net tonnage moving in one direction. However, the total capacity on the train density must take into consideration movement for the train in both directions. When the railway under the consideration is made up of several divisions on the branches, well, the separate estimates should be making each rail on the branch line. The following factors, formulas, computations, and the planning consideration, since the locomotives are prime power units. These are hauling capabilities must be established. Therefore, to establish locomotive power, pulling power, certain factors must be computed. The factors using the initial planning worst case situations. One of the implemented of the intelligence data permits and plans may be modified. Tractive effort. 10.6. Tractive effort is a measure of potential power of the locomotive expressed in pounds. It is a horizontal force of the locomotive wheels exerting on the straight level of the track before the wheels of the slip on the rail. Locomotive tractive effort is included with the data supplied at the manufacturer. Whether such data are not available, the tractive effort must be described in paragraph 10.7 and 10.8. Starting a tractive effort. The power is exerted by the locomotive to move itself and the load of the hauling of the data is at an STE. Stop it at the STE. Is corrected by the adhesion of the driving wheels while maintaining the railways. The traction effort expands exceeds this adverse factor. The driving wheels will slip. Normally, they are adhesion factor when the railways are in dry. It's 30% of the weight of the driver. When the railways are wet, the factor is reduced to 20%. However, the planning purposes of 25% is used for the diesel electric locomotive weighing 80 tons and 160,000 pounds on the driving wheels of the ST or starting traction effort computed as follows. The starting traction effort is weight of the driving wheels on the pounds equal divided by 25% adhesion factor of 160,000 pounds over 4, and for a starting traction effort of 40,000 pounds. Continuous traction effort (CTE) is an effective required to keep the train rolling in as standard. The modem of the train increases the traction effort necessary to keep the train moving and diminishes rapidly. The continuous traction effort of the diesel electric locomotive is approximately 50% of the starting traction effort. Locomotive can continue to exert the same force at the pulling a load as well as attaining and starting a load. The continuous traction effort of the diesel electric locomotive weighing at 800 tons or 160,000 pounds or driving wheels is computed as the continuous traction effort over equal to the STE or starting traction effort equal to 40,000 divided by 2, which gives you a continuous traction effort of 20,000 pounds. A draw pull bar is the is the actual pulling ability of the locomotive, deducting the traction effort and energy required of the locomotive itself. Planning 20 pounds per ton on the locomotive weight as the traction effort is as follows. The total locomotive weight is given in the 80 STS tons, or 80 S tons times 20, which gives you 1,600 pounds, and so there's continuous traction effort of 1,016,000 pounds equal to the draw pull bar, or the starting traction effort divided by of the 160,000 pounds divided by 4 is 40,000. The continuous traction effort of 40,000, and the draw pulley bar at 20,000 minus 1,600 equal to 18,400 pounds. Maximum draw power pulley can be exerted only at the low speed of up to the 10 miles per hour and limited long length time. At high speed diesel electric locomotive, the draw pull bar diminishes rapidly because the electrical bar and the traction motor cannot be held under the heavy starting voltage and amperage. The generated motor would also burn out and load continuing for the longer time of the locomotive reaches the speed of 10 miles per hour. The rolling resistance. Yo. Rolling resistance. The force components acting on the train direction parallel with the traction which tend to hold to retard the train from moving. The constant rolling resistance. The following are components of the rolling resistance: friction between the railway heads, the treads, and the flanges of the wheels; resistance due to the undulation of the track under the moving; internal friction of the rolling stock; resistance of the still air. Although there is no absolute figure to be used in the rolling resistance table, the 10.1 shows the safe average values of the theater operation. Grade resistance. Grade resistance is offered by the grade and the progress of the train, and is caused by the activity of the gravity, which tends to pull the train downward into the military railway planning, using the factor of the 20,000 multiplied by the percentage of the grounding resistance. 1013 curve resistance. Resistance offered by the curve progressing in the train. No complete satisfactory theoretical decision of the curve resistance has been published. However, the engineers in the U.S. allows a 0.8 to 1.1 ton per degree curve. In military railway preparation, the factor of 0.8 pounds multiplied by the degree of the curvature. The safe average values are exceptional good or 5, good to fair at 6, fair to poor 7, poor is 8, and very poor 9 to 8. Weather factor. The weather factor reflects the percentage of the adverse effect of the cold weather on the hauling power of the locomotive. Experience of the tests have been proving whether the outside of the temperature drops below 32 degrees Fahrenheit, the hauling power of the locomotive is decreased on table 2, the page 10.8, and it shows the weather factor of the following varying degree figures. The 1015 wet weather usually regarded local temporary and considerably absorbed average figures. However, the countries have been extended with the wet seasons and monsoons, fogs, and so forth. The loss of the tractive effort of the slippery rail may prove serious in sanding facilities of the lacking inadequate. The applicable reduction is a matter of the judgment. However, the general tractive effort will not be reduced unless not to less than 20% of the weight of the drivers. The most average temperatures, the hauling time, loss in hauling percentages, and weather and percentages are shown in this table. In table 10.2, the effect of water upon hauling power of the locomotives. The gross tailing load. The gross tailing load of the maximum tonnage of the locomotive car can move under the given conditions. For example, curvature, grade, weather. For the diesel electric locomotive operated multiple unit operation, the gross tailing load is equal to the sum of the gross tailing over all locomotives used. However, the locomotives are not electrically connected to multiple unit operations. Deduct 10% of the total GTA gross total loading for the GTL or gross total loading for the human element involved. Determine the gross tailing loading, combining the factors discussed in preceding paragraphs, is using the following formula: gross tailing loaded over the draw pulley versus the workforce by the railroad resistance by the GS. GS is what? GS. GS is N plus the CR. The GTL, where the GTL is the gross promoting alert. Your curve resistance, grade resistant, rolling resistant, weather factor, draw pulley, and gross trailing load. Obtaining the gross trailing load actual the foreign and captured locomotives for what the title is no information is available as quickly as the track of the car may be is available. The net train load. Net training load is a payload carried by the train. The total weight of the car is unloaded and the gross weight. The light weight of the car, an empty car is in the tear. The difficult between the gross weight and the tear of the net training load payload of the train for military railway planning purposes. The net training load is 50% of the gross training load. For the formula calculated as the net trailing load is equal to GTLX times 0.5%. The train distance density. The number of trains that may be operated safely over the division in each direction during the 24-hour period is known as the train density. The work trains are not including or computing the TD. However, the precedence of the division of the amount of the block of the main trackage of the resistant destination of the railway division. The TD may greatly vary the division depending on the following condition: the length of the main line, number of the location of the passing tracks, yard and terminal facilities, train movement, the control factor, facilities, procedure, availability of the train, crews, and motive power, and the rolling stock. On single line tracks, passing tracks generally are 6 to 8 miles apart, and multiple tracks are generally considered as double tracks, since they often is necessary to remove the portion of the all third and fourth tracks to maintain a double track line. The capacity operation turnover the cars of the train into terminal yards must be considered into either the definite experience, the intelligence factors, the inferences for related information. 1022, the rule of thumb formula determining the single track and designated primarily determine train freight train density, both responsibly accurate on lines of the passenger trains do not exceed 20% of the facts. Rule of thumb determining the train density. If another information available, evaluate the potential train density on the railway line. Train density is 10 of the single track of the 15 double track on each direction in the planning. The formula determining a single track. If the information is available, the following formula is determined by the train density specified railway with division and determined with the number of the tracks that do not include the less than 5 miles or 8 kilometers apart. The passing tracks should be uniformly spaced throughout the division, and the TD or the train density equal to the number of the passing cars and passing tracks plus 1 divided by 2 equal to 24 times the S2 LD. S1 is the constant number of the trains that can be run if there's no passing tracks. 2, the constant of the converting in each direction. 4 is the constant number of the hours per day. S is the average speed, and LD is the length of division. The computation of the train density results in the fraction. The result is raised in the next higher whole number power. The net division tonnage. The net division tonnage is the tonnage of the S tonnage on the payload, which can be removed on the railway division each day. The net tonnage division includes the railway operating supplies that must be programmed. The movement of the formula, the net division tonnage is equal to the net train load divided by the train density. Compute the net division tonnage for each division. End and delivery tonnage. In military operation, the end of delivery tonnage is the tonnage of the S tons of the payload that may be delivered on every railway line each day. All rail movement for the end of the delivery tonnage is equal to the net division tonnage of the most restrictive division. Here's determining the average speed values. Yard capacity. 1027. The capacity of the yard is not determined based on the planning factors. Planning the formula. The following describe the planning of the factors. The planning of the formula. The classification of yards is described below. The planning of the factors. The determination of with and without receiving the following forward yards. Planning factors. The classification of yards. 1028. The following factors are based on the day and night operations based on using the planning purposes of the 2 or more mainline railways intersecting the major terminals of the facilities while having duplicated accordingly. 1029. The flat switching capacity of 30 cars per locomotive per hour. This includes the time switching and gauge the push cars. The are based on the foreign equipment. The hump switching capacity of 45 cars per locomotive per hour. The number of the cars at any given in the classification yard should not exceed 60% of the yard capacity, which exceeds the yard capacity. Switching the room decreasing the operating efficiency. Sacrifice. Length of the track classification generally is in one train length and plus 20% plus 300 feet. 91 meters. Track and other track length within the local terrain characteristics and railway equipment of the requirements. 1032. Depending on the yard layout, the number of the switches, engines, pair switcher that may be employed, the operational load freightway classification yard may be vary from 1 to 3. Therefore, one of the switching engines may be handled by 30 to 60 cars per hour. 3 switching engines may handle 90 to 180 cars per hour. The function of the switching engines include the following: one switch engine at the head of the receiving yard, preparing the cuts for the cars switching; one switch engine switching and other cuts for the division of the classification yard; one switch engine for the opposite engine of the classification yard, coupling and making the switching room. During the slack traffic, one of the switching engine may be used for all functions of the switch engine functions above. It also uses the classification yard property do not include the engaged supporting other internal operations. 1033, the average time of the car remains the classification yard 8 hours. The classification yard of the traffic changes or averages in 3 times a day. Some cars are maybe held at 48 hours. Other may clear within other clear less than 8 hours. Planning formulas for classification yards. They may use the following to determine the classification yards for the requirements and capabilities. Determine the required length of the yards of the following: the LT, the ACT divides the LC versus times 1.23 is the 300 feet or 91 meters. LT stand for the length of the train, ACT average cars per train, LC the average length of the car, 1.2 or operational factor to allow overall length of the car coupler rather than the car length, 300 feet clearance distance of each of the end of the track from the point of the switch to the clearance. Determine the minimum number of the tracks from using the following. The NTR is the number of tracks required equal to the sum of the train density using the division of 3 turnover per day and 1.6 is the 60% factor of the static capacity. When computing the requirements of the terminal yard of the result of the ordering, the formula must be doubled. The formula does not necessarily apply to the railway head since classification of the car is not always necessary as the railway head. Determine static yard capacity using the following. The SYC is the static yard capacity in cars equal to the average car per ton times the NT number of tracks during determined in the paragraph, and number 34 per first bullet. Daily yard capacity is equal to 1.6 of the static yard capacity. The figure takes the account of the number of the cars in the yard at any given time will not exceed 60% of the static capacity. Planning factors for the terminal with and without receiving the forward. The following factors are based on how the train are moved in the terminal. The factors may be used in the planning purposes. When receiving in the forward yards, receiving and forward yards with the track operated by the operating terminals at 48-minute where trains operated in and out terminals at 48-minute intervals shall be a minimum of 6 plus one round in both receiving forward yards and half empty loaded in a general number of the tracks each equal to the train density divided by 5 plus 1 or the the number of tracks divided by the train density in the division divided by 5 plus 1. Without receiving the forward yards. Normally receiving the forward train yards will be in balance with classification mainline capacity. However, some railway dispenses the receiving the forward yards operating all trains directly into and out of the classification yards. In such cases, the classification yards daily capacity is reduced to approximately 25% to wall tonnage traffic in tonnage. Where there is two-way tonnage traffic in large terminal, the various yards are normally designed with the yards in each direction. For example, north receiving classification forwarding yards, southbound classification forward yards. Railway equipment, the requirements. The available equipment of the liberated for the occupied territory depends on the inventory extent of the destruction condition of the equipment, type of the fuel, local available of repair parts, the type of the coupling devices, many other such factors. Base allowance for the use of the captured local available equipment. Other judged and after evaluation, other main factors involved. Technical data concerned with the railway equipment may be found in the strategic survey space. Initial transportation studies based on the intelligence reports to the government in the railways in the peacetime, sometimes in the publication of the Railway Gazette, or British or Railway Age. American. The categories of equipment and consider the planning of this following: rolling stock consistent with the boxcar, gondola, flat cars, tank cars, refrigerator cars, and hopper cars. Road engines, motive powers that pull the trains between terminals, division switch engines, and motive powers that switch the cars from the yards and division terminals. Step-by-step procedure determining the railway equipment requirements. The Appendix B, the 1040, rolling stock. There are 3 classes of railway rolling stock. Their classes consist of freightway, passenger, and special freight. Compute the requirements special for the operation major supply installation areas on each railway in a system using the following formula to compute the requirements. Total railway cars by the EDT, or the end delivered tonnage over the divided by the average payload for the type of car times the total around time times 1.1. Obtaining the first factor of the formula formula for the part of this computation for one-day dispatch determines the number of the cars in which, by the type of the transporter, all given the point of the end delivery tonnage of the railway system. See in Appendix B of this third computation, the one DD or one delivery daily dispatch of the end delivery tonnage divided by the average payload for the type of car. The number of the cars dispatched the day of the load base of the or operations one day dispatch for the planning purpose. The number of the cars dispatched at the division terminal railhead or other dispatch considered the same as the number of the dispatch for the base operation. Using the formula shown in Figure 1042 to determine the rolling stop of the one day dispatch, computations are made for each of the type of the car used in box cars, gondolas, or flat cars. If the sum of the results of the type of the cars are computed in one day dispatch of the system, and see Appendix B for the third computation. 1044 turnaround time is the estimated number of the days required for the car to make the complete circuit of the railway system. It has days elapsed by the time of the car placed on the point of the origin forward, loading for moved in destination, unloading, the return of the point of the origin time that may be computed as follows: in 5 days to origin, 1 day to destination, 2 day in transit, 1 day forward of the movement, 1 day to train of the movement for each of the division, major division, portion of each division, which cars must traverse. The method rather than the actual hour basis is used to incorporate the delays of the time due to terminal and way station switching in the transit railway rail handling trains. 1045. The 1.1 factor is expressed in the 10% reverse factor. The reverse factor provides an extra car to the me to operate pre and commitments to certain classes of the cars to bad order cars needed for repair. 1046. Complete planning of the net for load per freight car before using 50% of the rated capacity of all freight cars except for the tanker car. The tanker car is related in carrying 100% of each of the capacity. The compute tanker car requires separate based on the local POL requirements. Tank car, the capacity of the computed turnaround disposition rolling stock of the operation railway system is shown in Table 10.4.2 on page 1016. This is 10.4 disposition rolling stock of the base and forward traffic and return traffic and at the head. From a 2-day dispatch, 1 day dispatch per division, and 1 day dispatch for the return traffic division, and 1 day dispatch at the railhead. The passenger, 1048. The passenger car requirements vary depending on the troop movement policy, evacuation policies, and the rest of the reoperation policies. The passenger requirements normally are fulfilled by the acquisition of local equipment, and exception of the equipment required for the hospital cars and for the train. The special requirements of these equipment are usually exclusive for the railway for its own use. The type of the equipment includes the maintenance way of equipment, work cranes, and snow removal equipment, and locomotives, and so forth. 1050. Road engines. You may determine the number of the road engines required for the operation over the given railway division for the following formula: TD, or the total train density times 24 number of the hours per day times the running time, the length division divided by the average speed plus the terminal time for servicing the terminal locomotives by 3 hours for the diesel electric locomotive and 8 hours steam locomotive equal to times 2 the consistent two-way traffic times 1.2 the consistent allowing 20% reserve. The RTT plus 2 TT the RT running time plus the terminal time divided by 24 is the engine factor provides the amount of motive power which makes more than one trip per day over the short division. Switch engines. No two ports, division, terminal, railway heads are alike designed in the operation. However, the functions of one main yards in each of the essential same. The receiving cars, the classifying, reassembling for the delivery forward of the movement that constitute the main functions at any yard of the switch engine and the type of the motive yards of these operations. 1052. The number of the switch required for the terminal base is the number of the cars dispatched and received and passing through the terminal per day. When the number of the cars being computed applied with the factors shown in Table 10.5 determine the number of the switch engines required at each terminal. 1053, a total number of the switch engines required for the railway line and computed with the 20% that is added to preserve the maintenance operational peak and set forth in Appendix B of this fourth computation. Table 10.5 is a switch engine required port of loading terminal is 1 per 67 cars dispatched and received per day. Division terminals 1 per 100 cars passing per day. And a railhead unloading terminals per 67 cars per dispatch per received every day. Okay, personal unit requirements. Requirements for the rail unit personals are based on the following: number of divisions of the system provided by the guide, determining the number of the battalions required for the operation, number of the train operation crew required for the operating road of the switch engines provided with the determining the number of the train of the operating companies required required in the system. Maintenance requirements: the rate weight of the locomotive rolling stock, and provide the guide of determining the number of the type of the units per units and required. On the basis of these factors, you can use the organizational capabilities, normal employment, and procedures to organize the command structure to determine support requirements. Road crews 1059, and computing the number of road crews net required for each of the division preparation time, and including the following: 2 hours of the originating terminal from crew receiving orders, instruction, test of the air, and the check of the train. Running the involved composed dividing the length of division average of the speed information is not available to compute the speed. The speed is maybe assumed at 10 miles per hour. Normally running at the time over the division will be about 12 hours. A 1 hour period for the final terminal to submit the necessary reports. 10:56 to allow enough time to the crew to rest, and running the normal does not exceed 12 hours. Although experiences shows the safety efficiency decrease in the crews and the work continuously daily shift for more than 12 hours. The time may not exceed the emergencies. However, if possible, the work shift shall be 16 to 18 hours. If the crew has enough rest period for the reporting of another run, sometimes it will be necessary to designate longer hours because of the length of the division involved. In some cases, enough time often between should be permitted to limit the average day shift to 12 hours. When determining the number of the road crews needed per division of using the following formulas: the fifth computation in Appendix B. Number of road crews, the total train density by times 2 times the running time length of division divided by the area average plus 3, which equals 2 hours allowed for preparation original terminal, and plus 1 hour for the final terminal, divided by 12, which is the 12-hour shift per road crew per day, by 1.25, which is the constant factor of all allowed is for ineffectiveness. Switch crews. To determine the number of switch crews required for the number of the switch engines used for each of the terminal must be known to the crews required per switch each engine. Use the following formula to determine the number of the switch crews required for each of the terminals. Do not compute the crews to reserve the switch engine. See the fifth computation of Appendix B. The number of switch crews SE times 22 times 1.25. This number of switch crews per engine constant factor to allow 125 to count to factor for ineffectiveness. The supply requirements. Railway supply tonnage is normally quite large. Planners are computing the end delivery tonnage should be ensured the considered person under the state, and the supply tonnage must be deducted by the end delivery tonnage to arrive the actual figurage of delivery to the units of the railhead. Following paragraphs discuss the method of arriving and specifying supply requirements, fuels, lubricants, and repair parts. Fuel consumption of the diesel electric locomotive. Table 10.6 of the 1016 contains an estimated average of the diesel fuel consumption of the gallons per train per mile. The diesel electric train locomotives in gallons per hour. The operation switch engines, the planning operation switch engines assumed for the 20 hours per day. The method determining the fuel and requirements from the engine gallons and the road locomotives of the switch engines as follows. The following is method determining the fuel oil requirements of gallons and road for locomotives. Multiply the train density of the first division by two-way travel, and the multiple result of the length of the division, the result of the two train miles per day for the division. Repeat the procedure for each of the division. Total day of the train miles for all the division. Multiply the total daily train miles by the fuel consumption factor to obtain the daily fuel requirement. Multiply the full daily fuel requirement by 30 to obtain the monthly fuel requirement. Add 5% to computed total to provide reserve contingencies. This is a fuel requirement sheet for the diesel electric locomotives. Gallons train per mile, gallons per hour, type of operation on the train on the type of locomotive. The following is method of determining for the oil requirements of gallons in the switch engines. Multiple total number of the switch engines required, and do not include the reserved engine. 20 to determine the total hours per train day operation. Multiple total hours per train day operation for the fuel consumption factor and engine occurred in Table 10.3. The result in the daily fuel requirement in the gallons. Multiple daily fuel requirements from 30 to obtain monthly requirements. Add 5% of the computed total to provide the reserve of the contingency. When coal is in the field, we use a reserve factor and percentage to 1063. Either use a lubricant of all moving factors of railway tools and appliances, machinery, and on all motive powers, rolling stock from the move. And the purpose for however the lubricants necessary for the operation of the motive power rolling stock is based on the estimated 1,000 pounds per month for each of the training over the direction over each of the division, and one day the following method to determine the amount of the lubricants required. Multiple train density. The first division 2 for a two-way travel for the multiple results of 1,000. The gives the amount of the pounds of lubricants required per the month for the division. Repeat these procedures for each of the division systems. The type of the amounts of lubricants for all divisions is determined by the grand total of the S tons required for the per month of the railway parts. And in another theater, the number of the kind of the supplies repairs for parts are seldom found and necessary. Maintain the motive power of the rolling stock by the units for planning only in the repair of the necessary maintenance motive power of the rolling stock is considered estimated. The repair parts required is based on the factor of 1.5 the S tons of the per month, and each moving in either direction. Each division using the following method to determine the repair parts. Multiple train density of first division 2A were traveled multiple to results of 1.5 to get a total amount of the S-ton repair parts required by the part of the division. Repeat the procedure in effect a successful division of the system. Total amount to determine the grand total of the S-tons required for the per month of this entire railroad. Okay, good judgment and certain assumptions required for the maintenance of always operational systems assumed for the train operated over each division of each tonnage and each division requirements the same amount of the operating supplies. The amount of the formulas accepted for the method of computing the operation supplies the base broad spectrum. However, the most refined method would be employing the following methodology in making place allowances. First division, no allowances made in the sense the operating supplies are available at the port of the terminal or base operation. Second division, allowance of 5% of the first division net tonnage, which means that it's 95% of the first division net tonnage will be held and over the second division. The third division, in addition to allowance of 5% of the first division of the net tonnage and the total deduction of 10% of the first division of the net tonnage, which leaves 90% of the tonnage. Overall tonnage should be held over the third division. Any additional allowance for the 5% of the first division tonnage will be made for each successive division with a corresponding reduction of tonnage hauled. Chapter 11, and that's Chapter 10, sorry, patch.